So for today's session, we'll be doing section 2.1, integer exponents in algebra. So first, let's have the following. So in the symbol, a to the n, okay, this guy here. So this is read as a to the n or a to the power n. And here, a is called the base, okay? N is called this guy here, exponent or power. And this expression as a whole is called an exponential expression. Okay. Sometimes this guy here, we'll just call it exponent or power, as well as the number n here. Okay. So that's just terminology wise. Okay. Now, if n is a positive integer, then this symbol here, a to the n, it's just the product of a times with itself with n factors. So a times a times a times a n times. Okay? So this is how we define this guy here if n is a positive integer. Okay? Now, some properties of exponents. Let's just recall this. So let a and b be real numbers and m and n be positive integers. Okay? So first, again, n is a positive integer. So let us define negative integer powers. So we have here a raised to negative n. This is 1 over a to the n. So you have something in the numerator with negative exponent, you bring it to the denominator. Of course, in here, we assume that a is not equal to 0. Because if a equals 0, then we have division by 0 in here, and that is not allowed. Right? Now, if you multiply two powers of a, so a to the m times a to the n, so this is the same as just adding those exponents there. So this is equal to a raised to m plus n. Okay? And if you divide, for example, you have here a to the m divided by a to the n, you just need to subtract the powers. So a equals a to the m over a to the n equals a to the m minus n. Okay? So this guy here follows from bullet 1 and bullet 2 in here. Okay? Now, suppose you have a power a to the m and then you raise it to power n. Okay? Then all you have to do is to multiply these exponents. So this guy here, it's equal to a raised to m times n. So you just need to multiply the exponents. If you have the two numbers being multiplied together, okay, and then you raise it to power n, this will be the same as multiplying the powers of a and of b. So ab raised to n, this is equal to a to the n, b to the n. So it's like you are just distributing this to each factor here. Okay? If you have division in here, a over b, and then you raise it to power n, it's the same as a to the n divided by b to the n, provided that b is not equal to 0. Okay? So this guy here follows from this bullet here and then this bullet here. Okay? Actually, it follows from this bullet alone, I think. But anyway, so you will have this property. Now, if a is not equal to 0, take note of this. If a is not equal to 0, then a to the 0, that's equal to 1. Okay? So a to the 0, it's equal to 1. So again, take note, a is not equal to 0. And if you see this symbol here, 0 raised to 0, this is undefined. Okay? This is not allowed in any mathematics that we know. Okay? So this is undefined. Okay? Now, take note that in here, you can distribute the exponent n over the product. So again, a times b raised to n, that's a to the n, b to the n. However, we don't have this guy here. Okay? So meaning what I'm saying is we don't distribute the exponent over the sum. So meaning a plus b to the n, this is not the same as a to the n plus b to the n. Okay? This is not the same as a to the n plus b to the n. So if we just look at this, for example, okay, you have, for example, you have 2 plus 1 raised to n. Or let's make this simpler. 2 plus 1 squared. Of course, you have here the parenthesis. You add first 2 and 1. So this is equal to 3 squared, and this is equal to 9. Okay? On the other hand, you have what? 2 squared plus 1 squared. 2 squared, that's 4. 1 squared, that's just 1. So this is equal to 5. And observe that they are not the same. So this is an example where this guy here um, is true. Okay? In a sense that you cannot distribute this power n over the sum. So again, you can distribute the power n over the product, but not over the sum. And a lot of students are doing this. So if you do this, you'll definitely get nothing. Okay? So don't ever do this. Well, I hope you remember not doing that. Okay? For examples, suppose we have this. We have 4 to the 3 here. This is just equal to. So by definition, this is just 4 times 4 times 4. And this is equal to 64. 4 times 4, that's 16, times 4, that's 64. Okay? For this guy here, of course, you can just get the square of 2 and then multiply it to the square of 3. Okay? So if you do that, you will have like 2 squared, that's 4, and then 2 cubed, that's 8. That's equal to 32. Okay? Now, for the sake of doing the property, okay, for number 2 here, so 2 squared times 2 cubed, according to the property from the previous slide, okay, if you multiply um, exponents with the same base, so a to the m times a to the n, that's just a raised to m plus n. So the same base. So in here, we have the same base. Base is equal to 2. So according to that property, this is just 2 raised to 2 plus 3. So this is equal to 2 to the 5. And you can use your calculator to evaluate this. This is also 32. Okay? For number 3, we have here 5 raised to negative 2. So from our property, you will have 1 over 5 squared. Okay? 1 over 5 squared. And this is equal to 1 over 25. Okay? For the next item here, take note that, well, you can easily evaluate 2 squared. That's just 4. So let us do that. 4. and then you multiply this to 4 squared, that's 16. So this is equal to 64. Okay? Now, for the sake of using the property, this item number 4 here, so 2 squared times 4 squared, we're going to use this property here. Particularly, let's start with the right-hand side. So you have different base, but you have the same exponents. Okay? Then you can just multiply the bases and then raise to the exponent, the common exponent. So a to the n times b to the n, that's the same as a times b to the power n. So in this particular example, you have base 2 and then base 4, and then each of them has power 2, so same exponents. So according to that property, this is just 2 times 4 raised to the power 2. And 2 times 4, that's equal to 8. So you have 8 squared, and this is equal to 64. So it is the same as this guy. So however you do it, either this way or this way, you should get the same answer. For this, if you use the property, okay, this is equal to what? So you will have 2 squared. So 2 squared divided by 3 squared. So you just distribute this over these factors, or in the numerator and in the denominator. So if you evaluate this, you will just get 4 over 9. And then here, you have a non-zero number, 1.025. You raise it to power 0. So this is equal to 1. And in here, let me write it this way. So you have negative 1 over 3, and then you raise it to power negative 2. Okay? To power negative 2. So what you can do, well, we use the same property as this guy here. So you distribute that exponent negative 2 to each of the numerator and denominator. Now take note, in here you have negative 1. So when you distribute this exponent, you make sure you include that negative symbol or that minus sign with the negative 1, with the 1. Okay? So a lot of students do this. So from here, they do something like this. Okay? And then 3. And then they will forget that this one here is, this negative here is actually attached to 1. Okay? And then they will end up with just negative of whatever. Okay? Whatever the answer here. So make sure that you always include that negative with the number. Okay? So this guy here, it's different from this. Because this guy, it means your 1 is being raised to negative 2, and then you negate it. On the other hand, this guy here, your 1 is being negated. That's why you have negative 1. And the negative 1 is being raised to negative 2. Okay? So please don't forget those negatives. Okay? Now, what happens to this? If you have a negative exponent in the numerator, you can bring the number to the denominator and then change the exponent to positive. Similarly, if you have a negative exponent in the denominator, bring that number to the numerator and change the sign of your of the exponent or the power. So in here, this will be the same as 3 squared over negative 1 squared. Okay? So the number 3 raised to negative 2 from the denominator, I brought it up to the numerator and then removed the negative for the exponent. Similarly here, the number negative 1 raised to negative 2 from the numerator, I brought it down to the denominator and then removed the negative. So if we calculate this, we'll just have 9 over 1 or simply 9. Okay? Questions so far? Okay? So again, when you have negative exponents and you want the exponent to be positive, you bring it to the other side of your this horizontal bar here. If the number was in the numerator, you bring it down to the denominator, change the sign of the exponent. Okay? And if your number is on the denominator, you bring it up to the numerator and then change the sign of the exponent. Okay? Okay. So this is not only true for negative exponents. There are possibilities where even if you have some positive exponents and you need it to have a negative exponent, then you apply the same rule. Okay? So if you have something like a over b, say this guy here, it's to the n, to the m, and you want them to be interchanged, okay? By interchange, meaning the location from numerator to denominator and vice versa. So if I'm going to bring the b here to the numerator, I should put now the negative of the exponent. Okay? And then this guy here, if I want to bring this to the denominator, I will have a raised to negative n. So there are times that you will need to put the exponent in the negative side. So just remember, when you bring one power from numerator to the denominator or from the denominator to the numerator, you change the sign of the exponent. So in this case, you have, it seems like positive n, you bring it to the denominator, it becomes negative m. Similarly for this, you have the positive m from the denominator here, you bring it up, you'll get the negative m. While in here, you have negative 2 as an exponent in the numerator, you bring it down, it becomes positive 2. And here, negative 2 as an exponent in the denominator, you bring it up, you have positive 2. Okay? So, in these examples, you have what? Actual numbers. Okay? You have actual numbers and therefore you can just use calculators. Okay? But what about the algebra part? Okay? In the algebra, a lot of times we use letters, just like these guys here, although they were assumed to be some actual real numbers. But these letters, we call these variables. So you apply the same laws of exponents even if you don't have actual numbers. Okay? So for example, this here. Simplify the following. Final expression must only contain positive exponents. Okay? So let us do all of this. Okay? Let us do all of this. So for example, let's have number 1. So in here, you have 2x squared cubed. So if we apply laws of exponents, this is equal to 2 cubed times x squared cubed. So you have this number here and you also have this x squared here. So they are being multiplied, you raise them to 3, so you can distribute this 3 to each factor here. That's why you have 2 cube and then x squared cube. Of course, here 2 cube, that's 2 times 2 times 2, you will get 8. Okay? For this guy, you have x squared cube. This means that if we use the property, we will have x raised to power 2 times 3. So you multiply this exponent with this exponent. And 2 times 3, that's 6. So that the final answer will be 8x raised to 6. Okay? Are we good with this? For item number 2, you have here a squared b to the 5 over x raised to 3. So we'll just combine the properties that we discussed. So you can distribute this 3 to each factor here. You have a squared cube b to the 5 cube over x cube. And then here you have a squared cube. You just multiply the exponents. So you will have a square 2 times 3 here. And then b raised to 5 times 3 here. And of course, x cube will just, you'll just copy that. And then finally, you now multiply this 2 times 3. So you will get a to the 6. And then here you will multiply 5 times 3. You will get 15. And then the denominator, it's just x cubed. And then make it a habit to box or encircle your final answer. So I would know where your final answers are. Okay? So that's for item number 2. For item number 3, take note, you have here a negative exponent and we want positive exponents only. So this guy here, you'll just have 1 over 1 plus r raised to positive 2. So from a number in the numerator, you bring it to the denominator. But now you have 1 plus r here, you square it, and there's nothing we can do. Okay, so this will be our final answer. Okay, questions so far? And then for number 4, so in here you have the same base, b to the 4 times b squared. The same base, you'll just have to add the exponents. So in the numerator, you'll just have b raised to 4 plus 2. For the denominator, you have your a squared to the 5. So in here, you just multiply 2 and 5 here. So a raised to 2 times 5 here. So if we simplify, we'll have b to the 6 over a to the 10. So this is our final answer for this guy. Okay? Questions? For number 5 here, so you have 2z cubed over 3z squared. You raise it to the power 4. So this is a product. This is a product. You divide that. All you need to do is to distribute this exponent 4. So that you will have 2 to the 4 z cubed to the 4 divided by 3 to the 4 z squared to the 4. Okay? And then we just simplify this 2 to the 4. That's 2 times 2 times 2 times 2. Okay? that's 16. And then here, z cubed to the 4, you will multiply it like this. I mean the exponents here, 3 and 4. But for this particular example and for the rest of the examples, we'll do the multiplication right away. So that here you have 3 times 4, that's 12. So you will have z to the power 12. And then for the denominator, you have here 3 to the 4. So if you do that, you'll get 81. And then you have z squared to the 4. You'll get z raised to 2 times 4. 2 times 4, that's 8. So you'll just get z to the 8 in here. Okay? Now, if you look at this, you have 12, you have z to the 12 over z to the 8. Okay? So same base, one in the numerator, one in the denominator. So we do the subtraction of the exponents. So in here, let's separate the number 16 over 81. And then you will have z. Okay? Or let me put that z, well, let me just raise it as if it's in the numerator. But anyway, you will have here 12 minus 8. So you have here 12 minus 8. And if you subtract that, you will end up getting 16 over 81 z raised to 4. So this is the final answer. Okay? That's one way to do it. That's one way to do it. Another way, since you already have the z cubed over z squared, you can simplify immediately this z here. Okay? So let's do this in another way. Okay? So we have 2z cubed divided by 3z squared to the power 4. So you can immediately separate that 2 over 3. And then for the z, you have here 3 minus 2. And then you still have the power 4 here. So if we simplify this exponent here, we have 2 over 3 quantity and then z raised to 3 minus 2, that's just power 1. Okay? So if you want, you can put this power 1 here. Okay? But most of the time, if the exponent is equal to 1, we don't put anything. Okay? So it's like your a raised to 1, this is simply a. Okay? But anyway, so you have exponent 4 in here. Now you can do the distribution. So you will have something like 2 over 3 to the power 4 and then z raised to 1 times 4. So basically it's just z raised to 4. If you don't put the 1 as an exponent, you put just, so a to the 1, you just put it as a. So in here, z to the 1, you just put it z as z. Then you'll just get this z to the 4 immediately. And then you can do this again, abuse of the properties. So let's do that. So you have 2 to the 4 over 3 to the 4, z to the 4, and simplifying this, you'll get 16 over 81 z to the 4. So you will end up with the same final answer. Okay? Question so far? Let's go to number 6. So let me clear this up. So now we are in number 6. So our 6 here, it's 3x raised to the power 3. Sorry, yeah, 3x cubed. And then you raise this product to the power negative 2. Divided by, you have your 4y squared. You raise it to the power negative 3. So there are several ways to do this, or at least 2 ways. So I'll do just one way. You have negative exponents here. Okay, you have negative exponents here. So I want to make the exponents positive right away, at least for these two guys. Which means that I'll bring this guy here, or I'll bring this guy here on the denominator because it's originally from the numerator. And this guy here, I'll bring it up to the numerator because originally it's on the denominator. So this is 4y squared. This time you now have raised to power 3. Then for the other guy, you have 3x cubed and then raise it to power 2. And then you can now start doing other properties. You will have 4 cubed and then y raised 2. So we immediately multiply. So 2 times 3, that's 6. So you'll just get power 6 here. And then for the denominator, you have 3 times, you have 3 squared in here. So I'll put it as 3 squared. And then x, here you have 3 times 2. So you'll get 6 again as an exponent of x. Then if you simplify this, 4 cubed, that's 64. So 4 times 4, that's 16 times 4, 64. And then you have y to the 6 divided by 3 squared, that's 9. And then you have here x to the 6. So this is the final answer. Okay? Question? Questions on this item? Next, let's look at number 7. Okay, let's look at number 7. So we have here 3x squared. So 3x squared, y raised to negative 1, z cubed divided by 27, x raised to negative 3, y cubed, z raised to negative 1. Then you raise it to power negative 2. So what I'm going to do, so in here is to manipulate first the one inside this parenthesis. So in here, I have 3. This is a constant. On the denominator, I have 27, but I know 27 is 3 times 9. So we can simplify that 3 over 27, okay, as 1 over 9, correct? And then for these numbers here, okay, for these numbers here, you compare those with the same variables. So x squared here and then x cubed. Then later you have y and y raised to negative 1 and y cubed. Then here you have z cubed and then z raised to negative 1. Okay? Of course, if you have negative exponents, you make it positive, okay? By bring it on the other side of this horizontal bar here. for the fraction. Okay? So, for example, you have x squared. Okay? You have x squared in here. It has positive exponent. And then this guy here, x cubed from the x raised to negative 3 from the denominator. You can bring it up to the numerator. So if you bring that up, the minus 3 becomes plus 3. Correct? So this is x raised to power 3. Okay? And then for the y, you have y raised to negative 1 in the numerator, y cubed on the denominator. So this guy here has negative exponent. You can bring it down. Okay? To combine it with the y cube. So you'll have something, still have y cube on the denominator. Then here, you bring it down to the denominator. From negative 1, it becomes plus 1. So y raised to 1. And then also for the z cube over z raised to negative 1, z cube will be retained in the numerator. Z raised to negative 1, we now bring it to the numerator and you'll have z raised to 1. Then all of this quantity raised to negative 2. Then you just simplify this. So x squared, x cubed, that becomes x to the 5. Z cubed over z to the 1. Z cubed times z to the 1. That's z to the 4 over. Then you have the 9 here, so you have that 9. Then here you have y cubed times y raised to 1. That becomes y to the 4. And you might be asking, what happened to the 1? Well, this 1 in the numerator, if you multiply it with any number, you'll just get the number. So we don't have to put the 1 in here. And then this is everything being squared. Sorry, being raised to negative 2. And then you want this to have positive exponents. Okay? So one way to do this is to distribute this negative 2 to each factor inside the parentheses. It's one way. Another way, you interchange the two guys here, the numerator and the denominator. And once you've interchanged them, you can now remove the negative sign. That's what I'm going to do. So I'm going to interchange this guy and this guy here, so that in the numerator, I have 9y raised to 4. Denominator, I will have x raised to 5, z raised to 4. And now, the exponent will be positive 2. Follow so far? And then, we now distribute these 2 to each factor. And then we will evaluate that. For example, you have 9 squared. That's 81. Y to the 4 raised to power 2. So that becomes y raised to 4 times 2. Okay? So this becomes y raised to 8 divided by x to the 5 to the power 2. So you'll just have 5 times 2. Exponent of x will just be 10. And then z to the 4 raised to power 2. So you have 4 times 2 again there. You'll just have z raised to 8. And this is the final answer.